Bonjour à tous! Bienvenue à ma chaîne YouTube aujourd'hui. Merci d'être ici et bon visionnage. Today on my workbench I have Barry's QuadraFire brand TASSB-93V.12A Pellet Stove Controller. Barry sent me this one because he was having issues with it, and most notably it would not drive his heater element. I believe, but I can't remember exactly, that he told me he did replace the heater element, and in spite of that, the controller still would not ignite it. So after discussing this with him over some phone calls and text messages, we agreed that he could send it to me. I received it earlier this week. I did some troubleshooting work on it. I found a couple of issues with it. I made those corrections. I replaced some parts on the circuit board, and that repaired all the issues that he noted to me. So at this point, I'm now ready to do final tests on his controller before I return it to him. As you can see, I have Barry's controller. It's connected to my test system, and my test system is made up of a few items. First, I have a temperature simulator here, which will simulate the fire pit temperature. I presently have it set to 75 degrees Fahrenheit. On the faceplate here, I have an actual auger motor. The shaft from the auger motor comes out the front, and I have an X marks the spot decal on it so that you can see it spinning during the video. I also have 4 light bulbs at the rear that simulate different functions of his pellet stove. The first one is the igniter, the second one is the combustion fan, the next is the auger motor in yellow, and at the far end in red is the convection or room fan. For this controller, we will not see the red convection fan light come on. That is controlled by a thermal switch inside of his stove. I also have a standard thermostat here, just like the one that you might have on your wall for this type of controller, and a calling for heat indicator lamp, which we will see come on and off as we call for heat. So I'm at the point now where I can apply power to the controller, and when I do, we'll see some of the lights at the back come on. Because I'm not currently calling for heat, we only get one light come on, which is the combustion fan. So the fan for the firebox would be running, and that's a safety thing as well, so that we can make certain that any residual material in the firebox gets pushed out the exhaust stack. So as we see, we don't have any lights on here. We're not calling for heat, and the thermostat is set low, and we're at a room temperature of about 75 degrees Fahrenheit. Now, if I were to call for heat by asking the thermostat to do that, we'll see some of the lights at the back come on. We see the igniter has come on, and the auger motor has also come on. We still don't have any lights here, so that's normal, but the calling for heat light is on. Let me see if I can make that a little bit better for you. There you can see it's on. If I turn it off, call for heat light goes off, and we see lights at the back go on and off. So that's all normal. So we're now calling for heat, which means that we're dropping pellets into the fire pit, and the igniter is on, so it's going to try to slowly heat up to the point where the pellets in the stove itself in the fire pit will ignite. So as the heater heats up, the temperature of the fire pit will slowly increase. And I'll say one more thing. I have noted on this controller here that the green light here, the green light will come on at 330 degrees Fahrenheit, and the red light will come on at 1450 Fahrenheit or thereabouts. So let's increase the temperature as the fire pit slowly increases in temperature. Some of the pellets will start catching fire pretty soon, and I approach 330 degrees. And as I do that, I expect the green light to come on. There it is. We just now saw the green light come on. I'll back that off. On. Notice it's on and off, on and off. So that's happening, but nothing really happens at the back. The lights are still on, which means the combustion fan is still blowing, the igniter is still running, and the auger motor is still spinning. Notice here that the auger motor is spinning because we see X marks the spot spin, and you might actually hear the motor spin in the video. So as I continue to increase the temperature, now the pellets are catching on fire, the temperature is rising, and we're going to go to about 1450 degrees Fahrenheit. As I continue to increase, we should see the red light come on, and simultaneously one of the lights at the back should go off. The igniter lamp, there it is. The red light has come on, and the igniter has gone off. So if I lower that, see what's happening there? I'm dropping down. I'm dropping to about 1424. Igniter is on. I increase to 1450. The lamp goes red. The red lamp goes on, and the igniter at the back goes off. So in this mode, the pellet stove would be in self-sustaining mode, which means the igniter is not on. We're feeding pellets into the fire pit. The fire is roaring at 1450 or higher, and everything is going fine, and it would continue doing that until we run out of pellets, or somebody comes by and says, hey, the room is too hot, or the temperature senses heat and shuts things off. Now we're still in the red zone, the fire is still roaring, but the room might cool a little bit, right? If we simulate the room is cooling, and all of a sudden it calls for heat, the thermostat calls for heat, and notice the auger motor comes back on, drops more pellets in. Those new pellets will catch on fire, the temperature of the fire will go up, 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 the room will warm up, and the thermostat will say that's enough, and shut things down. And then the room will slowly cool because our fire is dropping, fire is not roaring so hot anymore. Again, the thermostat will call for heat, and there we go. Auger gets back to work. So finally, at the end of the day, somebody might come into the room and say, enough of this, let's shut things down, it's getting too hot, and we're going to be away from the house for a while, so we don't need it. So we turn off the thermostat, the combustion fan keeps roaring, and the fire will slowly drop, and we see the red light disappear. And as the temperature continues to drop, we'll go below 330, and at that point, the green light will vanish. I'm slowly approaching there's 400, so pretty soon the green light, there it is, it's vanished, and the room goes back to approximately 75 degrees Fahrenheit. Maybe a little higher. That's 75 degrees Fahrenheit. Anyways, so that's the full operation of this controller. As you can see, Barry, it is fully functional. The two parts that I replaced are definitely related to the problems you were having. In addition to the tests that we just did, I wanted to note that there are 5 timers in the control box, and I checked all those 5 timers, and they're functioning correctly, especially the one for the combustion fan, which will keep the fan running for approximately 10 minutes once you turn the controller on or after the fire goes off, so that's all functioning correctly. So Barry, I do want to thank you very much for sending me your controller for repairs. I appreciate it very much. Should you have any questions, please feel free to contact me. In the meantime, for all you other viewers out there watching this video, if you have a controller of your own, whether it's a QuadraFire or USSC or Breckwell, and you have a service need for it, please feel free to contact me. I'd be more than happy to discuss that with you and answer any questions you may have. But in the meantime, I hope you'll take a few seconds to give this video a thumbs up and subscribe to my channel. I would appreciate that very much. Thanks everyone. Bye bye.